Figure 6.25 and 6.26, function template maximum. Now, in this example, we're going to introduce another concept with respect to functions. It's called a function template. And basically, a function template is a generic representation of a function that can be used to actually generate source code for different versions of that function for different data types. Now, it's basically a way of causing the compiler to do function overloading for you. What I'd like to do in this example is to take a look at the main program first, and then we'll look at what's actually defined in the maximum header file, which is our maximum function that can take 3 arguments and return the largest of the 3. Now, if you take a look here in main, you'll see that we declare 3 integer values. We ask the user to enter those 3 values, and then we call at line 19 and 20, or we output at line 19 and 20, the maximum of those 3 integers. And the way we do that is by calling a function called maximum that takes 3 integers as an argument and gives us the largest int. And similarly, at starting at line 23, we declare 3 double variables. We ask the user to type in 3 double variables. And similar to what we did up above, we print out that the maximum double value is, and then we call a function named maximum with 3 double values. And finally, we do the same thing one more time with characters as well. Now, based on our discussion in the previous video about overloading functions, what you might expect is happening here is that there's a version of maximum that receives 3 integers. There is a version of maximum that receives 3 doubles, and there's a version of maximum that receives 3 characters. But in reality, in this example, there's one definition of maximum that receives 3 of the same type of thing, and the compiler then generates a version of that function that is specific to type int, specific to type double, or specific to type char. Now, before we actually look at that template, let's go ahead and run this program just to show you that indeed it works. So initially here, I'll type 3 integer values, and you'll see that the maximum value is 3. I'll now type 3 double values, and you'll see that the maximum value is the largest one that I typed, 3.3. And by the way, notice in the first case the largest value was at the right. In the second case it's the first argument. And now we'll do 3 characters. Let's do ACB. So the first character is the largest character, is in the middle, and you can see that the maximum character value is C. So clearly my maximum function or functions are working, but the question is, what's the implementation that's allowing this to happen? And basically what we've done in this header file here, maximum.h, which I should have put up here in the header files folder, it contains, a definition for a function called maximum. But you'll notice that we did not specify int for the parameters. We did not specify double, 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 and we did not specify char, char, char. We specified a generic type name, which we've called t, which is a commonly used practice to represent a type. And that type name is introduced by line 4, which begins our template declaration. And in the template declaration's angle brackets, we indicate that T represents a type name by saying class T. We can actually also use the word type name here as well, which might make it a little bit more understandable in terms of what we're writing here. Those two words are actually interchangeable in template definitions. Basically what happened is when they first created this concept of templates, they decided to use the class keyword here, which is what we had originally, and then they found that to be a little bit confusing, because in reality with a template you can technically pass in any data type you want, so class has a certain connotation to it, and therefore they introduced the type name keyword as well. So class or type name as a keyword here introduces the identifier T as just some generic type name. Now, you can then use that generic type name in the function's header and also in the function's body to represent a data type. And in this case, what we're saying is that the maximum function needs to receive 3 values that all have the same type. So I can pass it 3 integers, 3 floats, 3 doubles, 3 characters, 3 booleans if I wanted to, etc. And then separately, this function returns a value of that same type as well. Now, the way that this works is well, let's look at the code first here. Within the body of the function, I'm creating a local variable of whatever that generic type is, called maximum value, and I'm assuming that the first value we pass in is the largest so far. Then I compare the second value we pass in to that maximum value, and if the second value is greater, we assign it to maximum value. And then if the third value is greater, we assign it to maximum value. And by the time we hit line 17, we have the largest of the three things, whatever they happen to be. Now, this template is kind of like a stencil. It's not actually a function yet. It's a template for a function, and we have to first tell it what type of function to generate in order to use it. And so what happens at compile time is when we encounter a call to maximum, the compiler first looks to see if there's actually a maximum function that receives three int parameters and can return a value. If there is, it calls that function. If there's not, it looks to see if there's any way that it can generate a maximum function that takes three integers and returns a value. And because we have the maximum template in this example, what it is then able to do is infer, because these three parameters are of type int, it's able to infer that the maximum function can be used to generate a function that receives three integer parameters. So it inserts int for t everywhere in the definition, and it actually writes a separate copy of this function without the template keyword and without the t's, with all the t's replaced with ints, and now I have a version of this function that is specific to data type integer. And when it encounters the next function call at line 30 here, it actually looks first for a version of maximum that's been predefined to take three double values. If it can't find one, because it sees that all of these are of type double, it can then go to the maximum template and substitute double for all of these t's and generate a version of the function that is specifically for use with type double. And finally, when we get to the character version of the call, it will generate a third version of this function that receives characters. So in reality, in this program, there are three overloaded maximum functions, but the compiler created them for me based on this template definition. Now, so this is a really nice way to be able to create type-safe code that works for specific data types by writing a function once and letting the compiler generate different versions of the function based on how you call the function. In our case, with three integers, three doubles, or three characters. Now, one thing you need to keep in mind is that anything you do in the body of this function has to be supported by whatever data type you are passing to it. So in our case, we're passing numeric values, and numeric values always know how to be compared to one another. So I'm always able to compare two integers to see if one is greater than the other, and I'm always able to compare two doubles to see if one's greater than the other. And I can compare two characters as well, because characters are really just the integer values of those characters within the character set. So the letter capital A is always less than the letter capital B, and the letter capital B is always less than the letter capital C, etc. So we can compare values of the three types that we were talking about. And so each template has some requirements associated with it, and those requirements are often determined by the operators or possibly functions that you're calling on whatever type is passed to the maximum function. So let's, for example, we already showed that this works with doubles, integers, and characters, but let's consider the fact that we might define a class called employee. So let's just go create here a class called employee. And I'm going to create an empty class definition just so I have a class. And let's declare three employee objects. Okay, so we created three employee objects. And now when I say maximum with E1, E2, and E3, and then I try to compile this, I'm going to get some error messages. And in those error messages here, let's actually, by the way, if you double click any window within the IDE, it'll pop it out as its own separate window, and that way you can work with it separately. So here, what it's saying is that the binary operator greater than sign for the class employee, it does not define this operator, and it does not define a conversion to a type that's accessible for use with that operator either. So what's happening here is the compiler sees in the original definition of the maximum template that we're using a predefined operator greater than sign, and that becomes actually a restriction on what you can do with this template. Every single data type that you want to use with this template must support the greater than operator. And that works with all of the primitive or fundamental types of C++, int, double, char, float, etc. But it doesn't work with class data types unless the definer of that class, the person in charge of creating that class, does what we call operator overloading for that class. So for example, we can do this with string objects. So let's just demonstrate. So I'm going to go ahead and declare 3 strings. And instead of reading them in this program, I'll enter AAA, BBB, and we'll do CCC. I need an equal sign there. And you can see that it doesn't know what type string is because I have not as yet included the string header file. And of course I need a using std : string, as you've seen in earlier examples as well. So now I've declared 3 strings, E1, E2, and E3, and I'd like to output the largest string is, and we'll output the result of the maximum call, and we'll follow that with an endl as well to create a new line. And now when we run this program, we'll see that we are able to compare 3 strings, and the largest of my 3 strings was the one that contained CCC. And the reason we're able to do that is the people who created class string also created the relational and equality operators for class string. And therefore, when I passed 3 strings to the maximum function, the compiler was able to see that this operator is actually defined for class string, and therefore allow a version of maximum to be generated that was capable of receiving 3 string arguments and returning a string as the result. So the compiler is going to enforce those types of restrictions on you, and one of the things that you need to keep in mind then is when using templates is what the requirements of those templates may be. So for example, when we get to the end of the second part of this live lessons product, one of the topics we'll be looking at is the standard template library, or STL. And within the standard template library, some of the collections that we can work with maintain data in sorted order. Well, you can only maintain data in sorted order if the data can be compared to one another in the first place. If you can't compare objects, you can't figure out what order they need to be in. So one of the key concepts that we're going to be focusing on when we get to the object-oriented programming part of this live lessons video product is a concept called operator overloading. And basically what it does is it allows you to make your own new data types work very much like values of the primitive built-in types, and use operators like the greater than sign to compare objects rather than fundamental values of type int, float, double, char, etc. And as I just demonstrated to you in this program, one such non-fundamental type, the string class, can be used with operators like this, and therefore with our maximum function template.